Sometimes, rather than being asked what the probability of a particular set of events is, we might be asked how many times does something need to happen, or what is the sample size before a certain probability is reached. Something like this might be in the context of how many shots must a shooter take to expect that the probability that they're going to hit the bullseye at least once is 95%, or something like that. So we have a probability threshold that we're given, and we need to find how many events need to take place for that to happen. Now, the idea of solving this is all based on the idea that 1 minus a probability, so 1 minus the probability that I have none, equals the probability that I have at least 1. So this idea says for me to hit the bullseye at least once, which is this, is 1 minus the probability that I never hit it, because that's every solution. So let's have a look at this in more detail. If I had, for example, a 10% chance of hitting the bullseye, that means I have a 90% chance of missing. And therefore, P equals 0.1 and Q equals 0.9. So if I wanted to know how many shots I needed to take to ensure the probability of me hitting the bullseye was a half, then what I want to do is I want to find out how many times would I have to keep missing until the probability that I didn't keep missing dropped below a half. And therefore, the probability that I've hit at least once must rise above that. So I'm going to have a look at this value here, Q, to however many shots I take, must fall below 0.5 so that I hit at least once. And then once I calculate this, knowing that Q equals 0.9 to the power of n, which is the number of shots I take, once I know that that equals 0.5, solving for n, I know how many shots I need to take so that my probability will fall below that threshold. And once the probability has fallen below that threshold, I've calculated this, and therefore I know what my probability is, or the number of shots I need to take for the probability of at least one success to occur. So in summary, when we're looking at the number of trials to have the probability of at least one success, we calculate that by finding out 1 minus the probability of all fails. And if we know that, then we can work out the probability of at least one success. Sometimes we might be asked for the probability of at least 2 successes. And to do that, we'll do the same, in the same way, we'll consider it's going to be 1 minus the probability of 1 or less successes, which is 1 minus the probability of 1 success, and then that minus the probability of no successes. And generally, we can work this out by remembering this is going to be nx, where x will be 1 of p to the x and q to the n minus x, which will equal n times p times q to the n minus x. My probability that I have 0 will always be q to the power of n. So I can use this, again, it's quite a formulaic approach to calculate the number of events or the number of shots I have to take until I have a certain number of successes. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.